Hello, this is Kurt Young, Senior Technical Marketing Engineer, and welcome to Learn at Kemp, a series of videos to educate you on Kemp technologies, load balancing, and application delivery in general. This is Technical Module 4. In this module, we'll discuss high availability configuration for the Kemp Loadmaster, multi-site load balancing using Geo, updating the firmware on the Kemp Loadmaster, and then finally backup, restore, and logging. A pair of Kemp Loadmasters can be configured as one logical device. This configuration is an active hot standby configuration where only one unit is ever accepting traffic. Units can be in different racks locations as long as the HA prerequisites are met, such as keeping them in the same subnet, ensuring that you have more than one interconnection between the two loadmasters to avoid data loss or lack of availability. Be sure to use NTP, Network Time Protocol, to keep times on loadmasters up to date. This ensures that times are correct on any logs and that CARP, Common Address Redundancy Protocol, message timestamps are in sync. Virtual MAC creates a shared MAC address for both units. When a failover occurs, the loadmaster will handle the MAC address handover too. This allows switches to keep the same MAC address and not worry about ARP caches or stale records. This is useful when gratuitous ARPs, using communicating changes in HA IP addresses to switches, is not allowed. Always confirm that the switch does not prohibit multicast, and make sure that IGMP snooping is off. When troubleshooting HA sync issues, initiate a UDP packet trace on port 6973. Once again, the location of the Kemp loadmasters in the HA pair can be deployed in different data centers. There are some prerequisites. A layer 2 connection is required, and latency must be low between the two locations. And again, multicast traffic is required. Providing HA at the Kemp loadmasters in a one-arm configuration is not enough. If both of the loadmasters were connected to the same network switch, and that switch were to go offline, then the entire HA pair would be down as well. Having the Kemp loadmasters in an HA pair connected to different switches will add an additional layer of redundancy. Now if switch 1 were to fail and bring HA1 down, HA2 would take over and still be able to communicate through switch 2. The same goes for two-arm configurations. You could also have the ability to use multiple uplinks using bonding, which was covered in Module 3. There's three separate components of HA: CARP, sync, and multicast. CARP will keep the checks on the health of the partner, decide whether to take the active role and accept traffic, and keep checks on the connectivity to the default gateway. Sync will keep the loadmasters up to date with any configuration changes made on the master. There are exceptions on what gets synced. Multicast keeps the standby loadmaster up to date on persistence. This allows the standby to seamlessly pick up in the event of a failure. You must ensure that inter-HA updates are on. When configuring a standard loadmaster HA pair, you'll have two nodes. One unit is HA first, and the other is HA second. You have the ability to set other parameters, like changing the HA virtual ID to something other than the default. The ability to select a preferred host is available, or keep the defaults of no preferred host. Also, set the layer 7 and update interfaces. If a spare NIC is available, use this to allow all layer 7 persistence traffic to be dedicated on the spare NIC. This will cut down on network traffic. HA checks are important. Failure to configure interfaces for HA will cause the unit to give sporadic results when failing over and failing back. If an interface is in production, it is best to use HA checks. Alternatively, if it is a heartbeat connection, it should be treated as a non-production interface and unchecked. Just to note, you must have 3 IP addresses per production interface, one for each loadmaster, and a shared IP address for the HA pair. When updating an HA pair firmware version, the process is fairly easy, and it can be done during business hours if absolutely necessary. However, it is always best to schedule the firmware upgrades and maintenance accordingly. Simply update the active LoadMaster first, or in this case LMA. On the reboot, this will fail over to standby LoadMaster unit LMB. Once you confirm that LMA is back up online, you can update LMB and reboot. This will cause the failover back to LMA, and there will be no downtime during this upgrade. Kemp LoadMaster also supports clustering. This is an active-active configuration which will combine LoadMasters to provide scaling out. Kemp requires a minimum of 3 LoadMasters to make up a cluster, but recommends 4. This can be scaled up to 8 LoadMasters. This is used for customers that generate massive amounts of traffic and transactions per second. This configuration also provides redundancy, as does high availability pair, should one of the LoadMasters go offline. Now, some customers need more than just high availability for their application. They may need site resilience. This is where Global Server Load Balancing, GSLB, or GEO comes into play. To start off, we ask the question of what is GEO? GEO load balances DNS requests. It's a smart DNS, and its primary function is to check the health of the application before providing an IP address for the clients to connect to. GEO is different from a simple DR solution. Kemp LoadMasters can be configured with GEO to be used as an active-passive failover, should a site go offline. Kemp also provides active-active configurations where all sites can be sent traffic. These active-active configurations can be used to route traffic based on geographic location or proximity of the client. GEO can be used for either internal name resolution or external name resolution, or both. In this example, we have a client looking to resolve the fully qualified domain name test.domain.com. The external client will check with the local DNS server. The local DNS server will forward the request to the public DNS for domain.com. The public DNS will forward the request to GEO since it's responsible for resolving the record test.domain.com. GEO will check the health, scheduling for the sites, and determine which site is best suited for this client. GEO returns the IP address for the client that made the request, in this case public DNS. Public DNS returns the results to local DNS. Local DNS presents the IP address for test.domain.com to the client, and the client connects to the application. Some typical questions around GEO. First, do I need GEO if I have an HA pair of LoadMasters? The answer to that is yes. An HA pair of LoadMasters will not provide the site resilience GEO provides. Can I use GEO instead of HA to have high availability across my data center? You can, however, you are only protected at layer 4, not at layer 7. It'd be best to have an HA pair of LoadMasters at the data center with GEO installed for full DR and HA requirements. Do I need GEO for every site? Ideally, yes. If you happen to only have GEO configured in one site and that site goes down, there's no way for clients to resolve DNS queries. GEO, or GSLB, allows for the use of DNS-based steering to send users to performing sites. Whether the application can support active-active distribution or active-passive distribution, GEO has the flexibility to be configured in many different ways to support the workload. DNSSEC helps prevent against cache poisoning using a set of extensions that provide origin authentication of DNS data, data integrity, and authenticated denial of existence. DNSSEC provides a mechanism to sign requests and prove the validity of the records in the given zone, and does this through a process called zone signaling. Whether GEO is deployed on-premise or in the cloud, it allows users to fail over between the sites in the event of failure. Or, steering traffic to sites based on users' location is strategic. Latency and application response time can have a major impact on the user experience. Geo can be configured to look at various options to overcome these issues. Various options for scheduling are available on the Loadmaster using Geo, all similar to the standard Loadmaster features except for location and proximity options. The options are round robin, weighted round robin, fixed waiting, real server load, and location and proximity based. Here we have two scenarios. We have an active-active, where two data centers are running the application both externally and internally. Round robin, location, or proximity scheduling could be used here. And then we have an active-passive configuration, where two data centers and only one providing access to the application and the other one acting as backup. Fixed waiting should be used in this scenario. Looking at the proximity and location-based scheduling, location-based will check the client's source IP and find the country that the client is connecting from. Geo will provide an IP address of the corresponding site. Proximity-based scheduling will check the client's source IP address and find the longitude and latitude of the clients, and will send the client to the closest geographic site. In this diagram, we see 7 sites, 6 of which are available. For the users connecting to these sites in US West Coast and Europe, they'll have no problem connecting to the local site. The site in South America is down, so when a user in Brazil attempts to connect to that site, they will be directed to the next closest available site. Global settings are provided when using Geo. Source of authority, ability to set the name server, the source of authority email address, as well as setting how often the check of the health of the sites are when configuring Geo. A cluster is a logical grouping of devices which can be physically defined as any IP address that can be checked for availability. Clusters allow for consolidated health check and also allow for grouping of real servers, load masters, and other resources defined in fully qualified domain names, allowing for site or data center level management of devices. Health checking of these devices can summarize the availability of the devices behind their services. Checking the ISP edge router will quickly allow for the detection of loss of ISP network connectivity. Checking the firewall, confirm that the ISP's network is available, and provide visibility to the first arm of equipment located in the data center. Checking the load balancer will confirm that the ISP is available, the network infrastructure is available, and the real servers are responding as expected. There are 2 methods for clusters. Load masters can be polled for a health check, and if it fails, it will mark everything behind it as down. Second is to use cluster checks, and the load master is polled and tell Geo which virtual services are up. Geo persistence, also known as stickiness, is the property that enables all name resolution requests from an individual client to be sent to the same set of resources until a specified period of time has elapsed. This ensures that users are able to retrieve and interact with session-specific data. Depending on how the client talks to Geo, it could give the wrong answer. If the client talks to public DNS and public DNS talks to Geo, Geo will think DNS is the client, and therefore location and proximity may not be as accurate. NSLOOKUP can always be used to test with Geo directly. Here's an example of troubleshooting Geo with NSLOOKUP. Again, if connecting from a client to the Geo directly, the Geo will keep the persistence entry for the request. If connecting from a DNS server to the Geo directly, the Geo will keep the persistence entry for the request as a DNS server. When troubleshooting, always set stickiness to the Geo to 0. You must maintain support to receive firmware updates for the Kemp Loadmaster. Simply log into the Kemp Support Center, click Download, and select the appropriate Loadmaster type and model. To update the firmware, navigate to System Configuration, System Administration, and Update Software. Choose the firmware downloaded from the Kemp Support Center and update the machine. If this LoadMaster is in a cluster, all active sessions will fail over to the standby unit as described in the HA section of this module. There's also an option to revert back to a prior firmware version should any unexpected behavior occur. Kemp provides add-on packages that can also be installed and managed here. Backup and restore of the Kemp LoadMaster can be accomplished from System Configuration, System Administration as well. The ability to select one or more of the components to back up is available. You can back up LoadMaster base configuration, virtual services configuration, geo configuration, and or the Edge Security Pack single sign-on configuration. SSL certificates must be backed up separately. These can be backed up from under Certificates and Security. Extended logs are available around Edge Security Pack related activities, such as user authentication or security logs. When using the Web Application Firewall, audit logs can be found here as well. These logs are vital when determining why traffic is not being passed through the LoadMaster due to security settings or rules. In regard to some best practices around HA settings, use the virtual MAC address, activate stateful failover. In regard to backup, back up the appliance configuration pre and post changes. And always remember to back up the SSL certificates as well. This concludes Technical Module 4.